on this computer. Okay, thank you. Okay, guys, thank you very much for coming. Sorry we had a delay because I had an issue with my computer here. So hopefully it finished not long. So today we'll be talking about a topic here, a very, very interesting topic for those who are interested to join in a telecommunication world. So we'll be talking about the networking and telecommunication, especially the signaling. Okay, and then we talk TCP and UDP. Not okay. This one is wrong. Okay, TCP, UDP, ss7, Sctp, and sigtran. Okay, this will be divided into two topics. I'll be discussing the basics and then telco signaling. And then we have a guest here, Jemmy. Jemmy will be talking about the telecommunication part. Yeah. So Jemmy and I were working in telecommunication many years ago. We were in the same company. But now he's currently based in Malaysia, still doing telecommunication while I'm doing many things. Okay, the agenda for today are there'll be introduction, prerequisite, knowledge, okay, telco signaling, and then ss7, Sctp, and sigtran. And then Jemmy will show you some configuration of how you can configure the sigtran, okay, with some of the software that can do sigtran or Sctp. Okay, so introduction. Oops. Yeah, so we are GLC, Garda Lintas Cakrawala. We are based in Bandung. Our areas are training and IT consulting. We do MikroTik, Ubiquiti, and Linux things. We also develop products like billing, Radius Manager, and then we also do regular events like webinar. My name is Achmad Mardiansyah. I'm based in Bandung. I'm a Linux user since 1999. MikroTik user, what else? Cisco users, networking users, PostgreSQL users, PHP users, Python users. Okay, many users. I also have what is it? A LinkedIn account. So if you have LinkedIn, and then we can connect. This is our past experience. We do networking in several countries. Most projects are related to networking or ISP. So like upgrade a new ISP, implement new routing protocol, and so on and so forth. Okay, about the webinar itself. Yeah, the webinar started in 2010, and then you are free to join, and then to be a presenter. Okay, so it's a forum for everyone. Okay. Okay, I can see some of you already introduce yourself, but if you don't mind, please introduce yourself once again. For those who were not introduce yourself previously, okay, at least you can tell me where you are from. Okay, are you from Africa or from Europe, or if everyone are Indonesian, and then I'll be speaking in Indonesia. Okay, so please say something in the group chat. Okay, just say where you are from. So I was wondering if there are people not from Indonesia, okay, because that's one reason why I'll be keep speaking in English. Oh, okay. So we got the one here from Africa. Okay, thank you. Well, so yeah, that concludes that I'll still speaking in English. Okay, let's continue. Prerequisites. Okay. I forgot to edit this one. So we assume you already know some basic of telecommunications, signaling, and then yeah, some stuff of telecommunication, and then also networking, because most of the technique here based on the networking that we know are most of the words are borrowed from the telecommunication world. Okay, so let's do review. Okay, so when we talk about telecommunication, it always starts in the from this thing. So in the early in the 1800s, so we know that the sound can travel over the media, so it can be heard from thread or wire here, and then after that we invent the electricity, voltage, resistance, current, okay, the total number of electrons that flows over a media, so that is current. So, and then we can put the sound into the electricity. So that's why we invented the speaker and microphone, so that we can talk over a distance, yeah, as long as we have a cable, right? So a problem arises. So when we have a person here, person wants to connect to each other, okay? So there will be a very messy connectivity between them, okay? And then this is the things that we want to avoid of. Okay, so this is early telecommunication. So we need to have a place where we can put everything centralized, okay, not very messy. So that's why we developed the CO, or central office. Okay, so this is how the central office looks like. And then it's really run by human operators. Okay, so that's why if you maybe if you heard about the telco operators, they are really in the beginning, they're really operators, human operators, like this one here, like this one over here. They are really a human, okay? And then in the early telephone, okay, so there is no dial pad. So no dial pad, no numbers here, okay? So it's nothing. What you can do is you are using this one. You do you move that lever, okay, turn around quickly, and then by doing that, okay, for example, this one, okay, so this telephone has no dial pad, so there is no number here. So what you can do is pick up the phone here, pick up the headset, the handle. Where is it? Okay, so you pick up this handle and then you turn this one, and then it will do dial the central office, and then somebody will pick up your request. So at that time, this person, it becomes a call center. If you are complaining, they will answer. And then they also do switching, okay? So switching means to switch from one point to the other point. So for example, this is you, okay? And you want to connect to this number. So it will do the connection from here to there. So it's really very manual switching. Okay. Also, so it means that there is no phone number. Yes, there is a phone number. Yeah. But when you want to call, you have to inform the operator here. So they are working 24/7 in the shift. Okay. They have to. You have to tell them, okay, I want to call number 5533, for example. Oh, okay. So wait a moment. They are doing the connection, and then you can call the number. So those ladies here or these gentlemen, they are doing call center function. They are doing a switching function. They are doing signaling function. Okay. And then the signaling that we are talking about here is the in-band signaling, because signaling is, so you have a data, right? Meaning the voice. So when we talk about telecommunication and then we talk about data, the data in traditional communication is just only voice. There is no SMS, there is no email, there is no YouTube, there is no website, nothing, okay? So when we talk about data, it's just a voice, okay? So that's the voice. Okay, maybe you will think it is very funny, but that time it was really sophisticated. Okay, so yeah, back to the topics. Okay, so they are doing call center, signaling. Signaling means it's a function so that a phone or a call is made, can be made. So for example, you are doing ringing, okay, informing that you want to call somebody, okay, so ringing is part of signaling. You want to signal something, okay, like a sign, okay. You want to send a message, but not the real message. The real message is the voice, but you have to tell somehow in the system that you want to do something, like you want to do calling and then do routing, for example. Yeah. So because this is one CO, and this is CO, for example, 1, this is CO2, this is CO number 3, okay. For example, there's a customer, this is you, okay. You want to call, this is your friends, okay, located in CO3. So it means that the operator needs to route the call from CO1 to CO3. And CO means central office. So everything is still manual. Yeah, if you're still thinking about the static routing, well, it's more manual than that static routing. Okay, so that one was the central office. Okay, really traditional central office. And after that, okay, human always keep make themselves better. So we have a modern exchange. In this case, okay, there is no human operators because they already replaced by mechanical switching. So this is how mechanical switching looks like. Okay, when I say mechanical switching, means it's mechanical. So it's made from a metal. Okay, yeah. So as you can see, there is a bar here where its function is to connect from that to that. So in this phase, all telephone has a dial number. So you can just dial the phone number, the destination phone number, and then it will connect to you. Okay. Myself, when I was in late 80s, okay, I still have experience. I still experience the rotary, the telephone without a dial pad. So yeah, like I said before, when we dial, we move the lever quickly in the rotary manner. And then I have to tell the operator that I want to call this number. Yeah, in the late 80s in Indonesia, eastern part of Indonesia, we still have that experience in the late 80s. And after that, they moved to the modern exchange. Okay, so switching is done automatically by mechanical, and then automatic signaling, also in-band signaling, okay. And then the data is still analog, okay, still analog. There is no 1 and 0, still analog. But yeah, so it has been automated, okay. So you just do dial, and then the central office machine here is really machine, okay. It's very noisy, okay, very noisy, because it's, you know, it's based on the mechanical things. Okay, you can see lots of metal stuff in the central office, so it's very noisy. In Indonesia, it's called STO, okay, Central Telephone Automat. Okay, STO means Central Telephone Automat. Automat means automatic, and then it's done by mechanical switching. And after that, it's much more modern. Okay, we step into the next phase, is the digital exchange. Here is the same, no human operators. Okay, the phone has a dial pad like this one, so it's the same. Switching is done automatically, okay, but this time is done by electrical switch. electrical circuit. Okay, so you have a circuit from customer A, you have a circuit from customer B, and then they are connected. So this phase is called switching. And then because we have integrated circuit, okay, or IC, integrated circuit or integrated chip, and then those processing is done by the things. Signaling is done automatically. So if you want to dial 01, 02, and then the exchange will understand automatically, and then that's why we have what is it? A phone number system. Okay, so you have area, you have a country code, you have an area code, and then you have we call it subscriber code, subscriber number. Okay, yeah. So this is done in the hierarchical manners. Okay, country code, area code, and then the subscriber code. Okay. So every central office, usually they have code. For example, this is your number. For example, 113. At the time, the numbering is very simple. Usually 3 numbers. And then this is, for example, is 31. This is 32. Okay, so your number here will be 31113. Okay, so this is your number. All right. Yeah. So we have a telephone system numbering system. Okay, from country code, area code, and then the subscriber code. And then in this phase, we already introduced by a digital data. So the data from here, when it's sent to the central office, is already 10101011, and so on and so forth. So that one is called integrated digital network, ISDN. Or for example, if you want to call A to B here, okay, so you call here, processed by the central office, and then we have a link here called trunk. So trunk is the cable that connects to central office, and then we have an access network here. So over here is called access network. Okay, so access network is the network that is roll out from the central office to the subscriber. Okay, so this is how it's done. So the digital part can be started directly from the customer. It's called ISDN a long time ago. Or it's done, the process of digitation is done in the central office itself. Okay, so that the trunk here is already 1 and 0. So it's already binary here. Okay, so that's how the digitation is done. So digitation, as you know, with the process of PCM, okay, usually PCM 30. Okay, PCM means pulse code modulation, where they are doing sampling, okay, sampling and then quantizing and then coding, okay. So sampling for 8,000 samples, and then each samples is coded into 8-bit. So total, okay, so 8,000 multiplied by 8 is similar to 64 kilobit per second. So this is where you get the idea where the numbers come from. Okay, so we are doing 8,000 sampling per second. Each sampling is coded by 8-bit. So in total, we need to be able to allow 64 kilobit per second. Okay. Okay. For CO, well, switching is done automatically, and signaling is still doing in-band. Okay, so it means that the signaling here for ringing, you cannot escape from the line that is doing the data. Okay, so it's the same line. Okay, same connectivity for data and the signaling. So same thing, okay? You are ringing through that lines. You are doing routing through that line as well. So there is no dedicated lines for signaling. Okay, signaling is just signaling. Okay, and then we are still talking about telecommunication, and then when I'm talking data in telecommunication is voice. Okay, and then we know that the voice is 64 kilobit per second. So if the signaling is also in digital format, and then that format and that signaling will be in the sent in the same cable like our data. Okay, so this is the digital exchange. Okay, moving on. Okay, so there's an idea. Okay, so what if we separate the signaling and then the voice or the data? So we separate those things. Why? Okay, here are the benefits. Well, actually, the things that drives humans is because money, yeah. Because humans like money. Humans, like capitalism. The producer wants to make more and more money, so that's why they invent new technology. So this is how it happens. So yeah, the idea is we try to separate signaling and then the data. In this case, is a voice. So again, we're still talking about telecommunication, and then in the telecommunication data, it's always called, it's only one, which is voice. Now, when we talk about data, it can be many things. Can be MP3, can be MPG or MPEG or YouTube or Microsoft Word, email, whatever. Okay. So, but when we talk about telecommunication, yes, it's traditional. Yes, I know. It's when we talk about data, it means it's a voice. Okay, 64 kilobit per second. That's it. So we try to do it off band. Okay, so we dedicate a separate links just for signaling. Okay, and then we call it CCS, Common Channel Signaling. So previously it's called CAS, Common Associated Signaling. Why? Because signaling is associated with the data. We cannot separate that. Okay, so that's why we call it. It was called Channel Associated Signaling. Okay, now we call it CCS. Okay, Common Channel Signaling. It means that the signaling is commonly grouped. Okay, so there will be a dedicated links just for signaling and nothing else. So the version that we are using is version 7. So that's why it's called CCS7, or we just call it ss7, okay, signaling system number 7. So here's the benefits. So we utilize voice link. So for example, this is CO1, CO2, this is CO3. Okay, so we have two links. So here the voice, okay, or data. And then here we have signaling link. Here's also we have signaling, and then we have voice. Here's also signaling, and then here's we have voice. Okay, so always two things. What about from the customer to the central office? Nothing changed. Okay, nothing changed here. So this is still called access network. Okay, access network, or yeah, access network. Yeah, still the same. Okay, either they are digitized directly from the end, so it's already 1 and 0 here, or can be still analog. Okay, so it depends on the technology. If it is digital directly from here, it's called ISDN, right? Okay, yeah, it's a technology that happens long time ago in 1990s. and then they have to pay more money for that. Okay. So again, here's the benefit. So we want to utilize a voice. So we already have voice. We want to utilize more. Okay. And then by separating the signaling and a voice, we can create more service, and then more service can create more money. Okay. For example, hunting. Okay. So if you dial and then it will check. Okay. You can send SMS, right? Yeah, so you send several texts, SMS, and then the SMS is using signaling, okay? Toll free, okay? Service numbers like 911 or 0800, okay? Yeah, so those kind of services, or for example, McDonald's or KFC or, you know, that kind of services, they're using ss7, yeah. Otherwise, we cannot do things like that. So yeah, that was the CCS. Yeah, so this is CCS. Okay, when we zoom, as I said, this is for signaling, right? If we zoom in, okay, so because we need to build, yeah, well, by changing to ss7, of course you have to build separate ss7 network. It means that you have to put more cables just for signaling, yes. So it means that you have to put more money, yes, true. But with more service, you get more money, right? So if we zoom in this signaling, and then what we can see is this picture here. So this is how the signaling looks like. Okay, so as I said, so we have a central office here, CO, and then here's the access network. Oh, this is access network. This is central office. Okay, and here's another central office. So this is A wants to call to B. Okay, A number or B number. So yeah, yeah. There's always two lines. First is for signaling, others for voice or data. Okay, and then here is, as we can see, between the central office, we can set up an SCP here. Okay. So this is CO1. Okay, so, and then see, this is can be CO2, and then this is SSP, service switching point. Okay, so this is the architecture. Okay, so in SS7 we have a service control point or SCP. So SCP is an integrated database or computer. Okay, and then we have MTP, message transfer part, is the refers to data circuit. Okay, and then we also have STP here. Okay, so it's similar like a switch. And then we have ISDN user part. Okay. So with the signaling 7, we have SCP. So here are the components of SS7. Okay, so SCP is this one over here. And then service switching point is this one. Okay, and then we have message transfer part between this one, SSP, to the SCP here. Okay. So for example, you want to call 0800. Okay. So 0800 123. Okay. So you call that number received by the central office, and then central office will ask the SCP, okay, I want to call. So there is a customer that is calling this number. Okay. To where should I forward? Okay. So it means that tell me the destination that I need to do for this call. Okay. Oh, okay. Wait a moment. I will check in my database. Oh, okay. So 0800 123. Actually, you can you can call it to this SSP. So most of these, what is it? Agent, call center agents is located here. Okay, then thank you very much for the information. Okay, I will do the call here, call to this exchange, and then moving to the end. Right, so that's how it works. Okay, so with the separated ss7, we can do signaling like what I'm explaining on this slide. Okay, so that was ss7 architecture, the components. Okay, and then here's the stack. Okay, so if you learn about the encapsulations, most likely you will see there is layers. Okay, so same thing with ss7. So as I said, ss7 only talk about signaling, nothing to do with the data. Okay, only signaling. Yeah, so this is level 1. It's called, sometimes we can use PCM30. So with the 16 signaling link or link set. And then we have MTP level 2, which is we can call it layer 2. We have a flag here, BSN, BIB, FSN, and so on and so forth. Okay. And then we have a MTP level 3 that is used for routing. Okay. So in ss7, we also do routing, and then the routing here it's not like you have a subnet and then you have to do route on that based on that. So but the essence of layer 3, which is the addressing, exists here by using the point code or PC. Here we have a point code of originating point code, and then we have DPC destination point code. This is originating point code. Okay, so every components in ss7, every component ss7 here, okay, they must have a PC. This must have PC point code. Okay, so to indicate, oh, okay, so you are this central office. It's like identity. It's like a router ID, for example. Okay, so I want to go to this router ID, and then my router ID is this one. Okay, so that's the ss7. And then when we move to IP, actually most of the time it's the same concept. You have a signaling, and then you have the data. And then for this, and then here, we combine both of them. Yeah. So every data, they must have their own signaling, and then those things is arranged in form of layers. Okay, we have a 7 layer here. Okay, we have from layer 7 to layer 1. Please do not throw sausage pizza away. So it's 7 layers. And then because we have 7 layers and each layer responsible for a particular function, and then there will be an encapsulation process. Okay, it's like this one. So this is your data. Okay, so same thing. So this is data, and then the data, when we talk about in IP network, it's a similar concept. You have a data, and then you have a signaling over here. Okay, so actually the 7 OC layer is used for signaling, correct? Okay, so all of them here are just for signaling. Is the things that we need so that our data can reach from source to the destination, correct? Yeah, so that's the purpose of signaling. In ss7, in telecommunication, we have a signaling. Okay, we have data, we have signaling. And then in IP, we also have a signaling as well. We have a data, and then we have a signaling, which is in form of layers. We have layer 3, layer 2, layer 1. And then we have a serious encapsulation. For example, this is layer 4, okay? Yeah, layer 4 has its own data, okay, where you can use a protocol analyzer like Wireshark or K12 or K15 to unveil those encapsulations. So this is how the layer 4 looks like. This is layer 3. Okay, layer 3, we have two options, either IPv4 or IPv6. And this is layer 2, or one example of layer 2. Layer 2 can be Ethernet or Wi-Fi. This is Wi-Fi. Okay. And then if you see, so there is a big overhead. So one box here, one square here is 1 byte. Okay, and you can see this is your hello. Okay, the things that you send over your WhatsApp, but it's not the data that we are sent. Okay, the data needs to be added by something, which is signaling over here. Okay, and then this part is data, and then also here. So this is your data, and this is your signaling. Okay, so same concept from telecommunication and IT. I mean IP world. Okay, so because we have a same concept, and then the human think again, why don't we put signaling over IP? We already know that IP has similar structure. Okay, so perhaps we can combine them. Okay, signaling over IP. So previously we know that when we think telecommunication look like layers. Yeah, okay. So we have a layers of devices. We have a layer of local loop, okay, like or access network, okay. It's a network from the exchange or center office to their CPE, customer premise equipment, yeah. And then we have the exchange itself, and we have wires, okay. So same concept, we have layers, but in different functionality. So in traditional networks, we have infrastructure layers, okay? We have a network, and then we have application. And every application, we have our own network, which is, well, not good for money. So you have a cable for voice, you have cable for video. A long time ago, when you subscribe paid video, yeah, or cable TV, yeah, it's different cables. And then you have data for sending email, it's different cables. So you have many cables for different services. Okay, wasting money. Right? So what if we combine all of them by using internet? Internet is using IP-based network. So everything will be based on this. So for that kind of services, many service, voice, email, video, TV, whatever, you name it, okay? And then you will put them into a single network that is capable for forwarding IP packets, okay? And then on layer 2, this is layer 2 infrastructure, you can use Wi-Fi, you can use WiMAX, 4G, 3G, ADSL, GPON, whatever. Okay, so this is just layer 2. But in layer 3, we combine all of them with IP. Why? Because IP is more open, has a standard, okay, and widely acceptable. Why don't we just put everything based on IP? Okay. Okay, so yeah, why we need standards? We put everything. The thing is, why IP is widely adopted, because standard, okay, and then IP has an open standard. So when we put signaling over IP, it's going to be like this. So as you can see, SCP is still there. Okay, we're still talking about signaling, okay. oops, maybe different colors. Yeah, so we have a signaling, like SCP is the brain, okay, for your service. And then we have a signaling gateway here, and then between them, it's a packet network or IP network. So inside here, you can use Ethernet, switching, routing, whatever. Okay. And then for voice, as I said, yeah, and then we have a media gateway here for that purpose. Okay, so over here, as I said, in telecommunication, we have separated network. Okay, in my previous slide, a long slide ago. Yeah, so as you can see, this is your signaling and this is your data or voice. Okay, we have to separate those things. So same thing in the signaling over IP. Okay, so we have a signaling over here. Okay, so this part is for signaling, and then this part is for voice. Then signaling. Okay, so, and then the signaling things here is based on IP network. Well, actually for voice, they're also based on IP. Yeah, and then this is your phone, okay. Your phone, okay, up to this. Your customer goes to that. Okay, as simple as that. Okay, so the next phase will be presented by Jemmy. Are you there, Jemmy? Hello. Jamie, can you turn on your camera, please? Oh yeah, Jamie is there. So, I'll be turning off my camera, not the camera, the screen share. Right, Jamie, off you go. So this is your part. You'll be explaining more about sigtran and then signaling over IP. Okay, over to you, Jemmy.
Okay, sorry, I'm not. Good evening, everyone. Not really familiar with this Zoom, but okay. I think this is the PPT that I create for your webinar. You can see my screen?
Yeah, sure. Yeah.
Okay.
Well, you can use PDF. Yeah, okay. So yeah, off you go, Jamie.
Okay. Maybe a very deep history already Achmad say for this telco history in the past, but I will talk about present the one that's still used today is called signaling transmission in telco. So this is a little bit history of me, just an engineer from 2006 until today. I handle the node called HLR, which is maybe you can see later where this node are located in the telco network. Until now, I'm senior engineer for subscriber data management in here in Nokia Kuala Lumpur. Okay, a little bit history of the signaling in the telco. Okay. I think Achmad already tell all this story about in GSM network earlier. We have a signaling connection based on the signaling system number 7, ss7. So earlier, this ss7 connection also used the PCM30 cabling. I think this is also already discussed. But in North America at that time, they know as PCM24 with transmission rate 2 megabytes for the PCM30 and 1.5 for PCM24. Separated in time slot 64 kbps and or 56 kbps. You can see if you are a IT engineer, if you do ping, you will get one time slot each is ICMP. You will send this 64 or 56.
Okay.
So So several transceivers were used for transmit SS7 message between signaling endpoint. Signaling endpoint is the one that Achmad said is signaling control point. So earlier, telco nodes were able to handle signaling method using a PCI card. So they don't use UTP like we see today, but actually before they use a PCI card in the past for this SS7. But then, because it's growing, then very slow, this SS7, the need of a more faster speed in the signaling, then it was replaced the SS7 with the IP base, and therefore the focus of IP signaling system known as sigtran. So we put the SS7 on top of IP.
Right.
So it will have a very higher speed lah. Okay, since we're talking about core network, this is the SS7 network that connect in our core network, because this is my background is core network. There's a HLR, there's MSC, there's a gateway MSC, there is SGSN, this is for packet core. There is SMSC for SMS. There is IN server for billing, and there is GMLC. This is for location service. But this one is considered as signaling control point. Between them, there most probably there is a signaling transfer point. So from HLR to MSC, you can put in the middle signaling transfer point. We will see what is the signaling transfer point and what is signaling control point later. Okay, now we would like to introduce the protocol called Sctp, Stream Control Transmission Protocol. So some organization developed a new protocol to replace the TCP or UDP. So before you see in the Achmad slide that you have a TCP IP stack from OC layer to TCP IP stack. In the TCP IP stack, you can see after the IP, you can put a transport. Transport in the first early age, it is put it TCP or UDP. But
yeah, we only have two options, yeah? Yeah, only two options for transport layers, which is either TCP or UDP. So this one here is new, which is called Sctp. So another animal on layer 4.
Yeah, this is the new transport developed for telco,
and
because
then,
TCP has this limitation.
Okay,
they have unnecessary delay because of so many headers you can see in the trace, and the stream oriented of TCP also have some issue in
yeah, we
telco.
have problem with synchronize and then act. You have to send and then waiting for the acknowledgement, right?
Yeah.
Yeah. Okay.
Like that. Yeah. Also, it's not support multi-home, which is needed for the telco. If you see the communication in the OC from A to B, A to C, you need a multi-home host. This is cannot support also be with TCP socket. Yep. Then TCP is relatively vulnerable to denial of service attack, such as synchronization attack.
Okay.
I think TCP also easy to attack by DDoS, right? I think Ahmad know better about the security.
Yeah. Okay, we can moving on.
Okay, Sctp protocol. Where is it located? Sctp is viewed as a layer between Sctp user application, HTTP user for short, and it is connectionless packet network service such as IP. So Sctp will be located between the IP and the Sctp user. Yeah. So this is Sctp. In the TCP/IP, you will see this as TCP or UDP as a transport service. But in telco, we use transport protocol called Sctp.
Okay.
The basic service offered by Sctp is a reliable transfer of user message between the peer Sctp user. So this will connect peer by peer, A to B. Like the earlier we're talking about is from like MSC to MSC, HLR to MSC, something like that, from node to node. So it's peer between peer to connect. Then it performs the service within the context of association between two HTTP endpoints. HTTP is connection oriented in nature. I think earlier we discussed about connection oriented in the past. We're using analog. So signaling will be occupied all the time when you make a call from A to B.
Yeah,
while
correct.
in the present day, you have TCP/IP, where they are connectionless oriented, where they're sending from A to B, but packet by package. They don't need to occupy all the time the signaling. So HTTP is actually the solution to make connection oriented based on package. So he is the answer of using TCP for the telecommunication.
Okay. So the requirement for telecommunication is the connection oriented. Okay. But we want to use, but unfortunately the IP network is based on packet. And then packet is not connection oriented. So HTTP is doing the connection while there is a mechanism in HTTP to make it like a connection oriented connectivity.
Yeah.
Okay.
Connection oriented like yes.
Yeah.
So
yeah.
This is HTTP is connection oriented, making TCP like connection oriented.
So actually the HTTP is using UDP. Okay. So they have a UDP on the lower layer, and then on top of that they are adding more and more header for HTTP. Correct?
Yeah, I think I never watched it all the header, but not that deep.
yeah. Okay. So next.
Okay. This is the sample part of sigtran that we use in telco. As you know, the TCP/IP, there will be the data link, IP, then transport, then application. Nah, in the sigtran, here more or less the stack that we have. The stack we have is like we have of course the data link, physical.
Layer 2, right?
Yeah.
Layer 2
1,
and
layer
then
2,
layer 3 with the blue color, and then on top of that is the signaling part, right?
Yeah, this one is called transport lah. We assume this is transport. So the physical, it will handle by the hardware. It can be Hewlett Packard, or we have Nokia has CBs. There's also Dell. Many hardware server provider lah for this. In the IP, it will be handled by the OS. It can be CentOS, it can be Red Hat, or other OS.
Or Solaris, we use Solaris a lot, right?
Solaris is in the past. I think it's expensive by now. Okay, so in the OS level, we still use the IP base, so you can do the routing in the for IP in the OS level. Then come to the top of the IP. Then there is a transport, HTTP M3UA, which is actually this is replacing of MTP3 user application. I think MTP already explained by Ahmad just now.
Yeah.
And then the SCCP layer. So this transport layer, these three stuff, usually handled by, we call RTP, Resilient Telecom Platform. So in our product, we use two supplier for this configuration, these three stuff. One Telesys, and the other one is Omni Software from Ulticom, which is, I think the company is Mavenir by now. So this one is the one who handle the
three things
configuration.
So this is very Nokia, yeah. So actually, the one on the left is the generic one. On the right is the implementation on your platform. Okay, so that can be in Ericsson they have different, but for those who are new to telecommunication, the diagram on the right is the generic one. Okay, so if you want to implement, and then that's the examples on the right. Is that correct, Jemmy?
In the left or in the right? Is in my left.
This is yes, okay. That's the left.
All right. Okay, this is in the right. Yeah. Okay, this is the generic stuff.
Generic one, yeah.
And this is the example. So this is too easier because this is you can say you cannot see these things when you are a practitioner engineer. You don't see this thing, but what you do is, and with this software, you configure all this transport stuff. Okay. Then of course there's a ticket, transaction, and there is map. In my field, it use map, but you have so many application protocol in the top here. There is a map, there is a run up, there is a camel, and many other.
Yeah, Jemmy, I think we don't have to deep into the Nokia things. Yeah, because maybe some of them are just for Nokia only. Better if you just talk about the general overview about the concept, not too deep into the products from a particular vendor.
Yes.
Right.
Wait, Ahmad. Need to turn off
the phone. Okay. Please continue.
Sorry, it's following my terms. Okay.
All right.
Okay,
so
then we can see the right stuff.
Mm-hmm.
Okay, this is ss7 in your left. It's in the past ss7. They have a Ulticom ss7 board using over TDM. Then there's a manager in each stack, like port manager, MTP3 manager, SCCP manager, ticket manager. But in your right, you will see the stack in the sigtran. So when the ss7 over IP, you use a LAN interface of OS, which is we normally know RG45 lah. RG45 or UTP cable, and this all come into software based. So there's a SCTP manager, M3UA manager, SCCP manager, TK manager. All of this will come into software. So you manage it by software.
Oh, right. So that means, okay, so the one on the right, my right, it is Ulticom ss7 board. So actually, for those who are new, actually the server is just a normal server. You can install Red Hat, you can install many things, but the card is a special card for SS7, which is the Ulticom SS7 card. So normally we use card for LAN, for Ethernet, right? But this card is special. It's used for SS7. Okay, so
Yeah.
that was a long time ago, traditional. We use a card that is dedicated for SS7. And then the one on the left here is the normal Ethernet card. Just normal Ethernet card. We use Ethernet, LAN, or any other technologies. Okay, mostly it's Ethernet. And then on top of that, we develop the Sctp, right? So we just use a
Yes.
commodity hardware instead of expensive SS7 card.
Yeah. In the
Yeah.
past, this is dedicated for the telco.
Yeah.
So only a specific supplier can supply this kind of card. And also the connection will be special also. You will know it E1 in the past, E1. It is expensive and it is limited and also slow.
Okay,
So by mapping this SS7 board into the IP, I think it's a very common by now that we can have RG45, we have a LAN cable, Cat5, Cat6, Cat7.
Okay. Yeah. Even up to gigabit interface, right? Mm-hmm.
Yes. So
okay.
So by now, all the special function already put into a software base.
Okay.
Yeah.
Okay. Next.
Okay. This is a little bit about telco core network entities current. Okay. In the right is the 2G, 3G network. In the left is the 4G network. So from your
you mean on the right?
On the right is
okay,
right?
That's all right. Okay.
Yeah, 2G, 3G network. Yeah, that's what I'm talking. Depends on where we see. In the left, this is the 2G, 3G network. This is where the HLR, MSC, SDSN, BSC. But this is all is service control point. So where is service signaling control point? Where is the signaling transfer point? You can put in the middle of this. Between HLR, MSC, you can put in the middle STP. Within HLR and SDSN, you can put in the middle STP. Even to here also, to the BSC and RNC. Okay. And of course, here there is a BTS. Then normally BTS going to the UE with the air interface. In 4G, I think we will not discuss the 4G, but just a little bit. This we have HSS. The development of HLR is become HSS. Then we have MME, E node B, UE. And in the 4G, you will have another node CSCF. Of course, the signaling in here will be very different with here. We already have diameter here. In 5G, you will have another protocol which is based on N1, N2, N3. And of course, the node will be different. Most of them is function, something like that.
Okay, moving on.
There is two types of sigtran type connection. The first is ASG-ASP. So in the early sigtran, around year 2000, the telco operator put what we call a signaling gateway. What the signaling gateway do? It will be the gateway between the endpoint that already supports sigtran and the endpoint that only support SS7. So ss7 is here MTP with PCM line. So if you have this kind of connection, this is the one who mapping between sigtran to ss7. But also this type you can use for connection between the signaling control point to signaling transfer point here. So
okay, so the one in the middle is the STP, right? It's the connect.
STP.
Yeah, STP,
yes.
signaling transfer point. Sorry.
Yeah. If you are STP, you have a control point, like say MAC or
yeah. So yeah, so it's like combining between SCTP and then the traditional SS7. That's the one on the left.
Yeah.
Yeah,
yeah.
And then on
in
the right,
in the early sigtran, we will find many of this type because there is many old entities still not support sigtran, so they need one entity called STP, signaling transfer point, but the function also says signaling gateway.
Yeah, okay.
But nowadays
everything is based on the SCTP.
Most of them will support this kind of connection, IPSP, IPSP. Sigtran, go to sigtran, like TCP/IP we see. So this is from the same stack lah. Between SCCP and 3UA and the IP. Then I think earlier I
message.
talked. Okay, sorry.
Yeah, I think this is too technical.
Oh, all right. Okay.
So perhaps we can. So these are the payload on the as we discussed before. When we send message, we have a series of encapsulation start from the data, and then on the data itself, in terms of SCTP, here are the example of the data. So look, again, when I'm talking data here is the signaling data, not the real data, not your MP3, not your YouTube videos, not your things. Okay, so this is purely for signaling. Okay, so because we have two networks, right? One for signaling, one is for data. Okay, so this is purely for signaling. Okay, so we will be talking about the data later on. Yeah, in the next webinar, I think. Okay, is that okay, Jemmy?
Okay. The message to you. I can see. Okay, this is the M3UA stack on top of SCTP. I already tell earlier about M3UA. The complaint message is will be like this. The data, of course, if you have data, then on top of it there will be data. The MAP map. There will be there's also Duna, there's also Dava, Con, Duku, and there's of course there's a document you can find about all these things.
Yeah. Okay.
Okay, this is the supply. One of the Nokia supplier for this sigtran software. It will be installed under the OS. Then you can run the MML command. We call MML command, main machine language. First, you should define your own point code. This is taken from my sample as HLR entity. You define your own point code. Then you define your LSET. LSET go to this STP. This is one of the STP that connect to HLR with the type ASP SGP, the one that we discussed earlier. Then you put the IP of the remote, the STP name here, and its point code. In telco, we don't speak about IP. We speak about point code. That's why they develop SCTP, because it will support multi-home. So we will send message to this point code via this link set. after we create the link set, this is like if you make a road, you clear first the land. You make the plan first. This is the link set. Then after that, you start to make the road. You define the link. The link name is here, and it will be put in this link set with this all parameter. This is the local IP, the remote IP. This is the mode. There are several options. The port used by the STP 4515. The port used by our entity. This is 2905. The in-stream, the out-stream, the RTO minimum. Of course, this
Request
you need
timeout,
to define.
Right?
Yeah, request timeout.
Okay.
You all define all this until heartbeat interval. This is by standard. I think the heartbeat, there is a 3 type standard. And I think this 3 second is one of the standard we use.
For the heartbeat, okay.
Yeah. Activate M3UA. Then after that, you create the root set. If you create, you see here, this is the name of the root set. Then the point code. The point code is the STP itself. .cerno. It's using this L set. So this routing set using a direct. Sometimes you can create a routing set not directly to this point code. You can have a routing set like you go from CTA to CTB. You go, your routing is directly, or you can go from A to CTC first, then to CTB. But in this case, I make the one that directly the routing. Then you also define the routing key here. Okay, just
for those who didn't know, Ulticom is one supplier or one manufacturer that sell the card, the ss7 card. So it's a special card for ss7. And then they also create a software that can send SCTP. It's called Omni Signalware, right? So the Ulticom is the name of the vendor, and then the software is called Omni Signalware, correct?
Yes.
Yes, correct. Okay.
And now they sell the software only, no longer.
They don't produce the hardware because everything
all
based on
can
the
be
IP
done
now.
with UTP. Can be done by UTP.
Correct.
And this is
another example command for SCP. I think this is too technical, perhaps.
Too technical. Okay. All right. This is just example lah.
Yeah, example. So guys, as you can see, when we define a connectivity in telecommunication, we are based on point code. Okay. So in the beginning, we need to set up a topology for our telecommunication network. How many SCP, and then every SCP must have a point code. Okay. Is there any more slides, Jemmy?
Yeah, just sharing my sample.
Oh yeah. Here's the trace. Okay.
Yeah.
As you can see, this is the sigtran, right? The SCTP. As you can see, it's
no. This is UDP and TCP. This is the sample that we talked earlier. Yeah. Of course, UDP not reliable because it only sends. It doesn't care whether it's received or not. In TCP, it's reliable, but there's an unnecessary delay. You see the header from the stream until all this.
There is an acknowledgement process. Yeah.
Yes. This is create unnecessary delay. And this is SCTP trace. Same about heartbeat. This is about sync, and this is about heartbeat. You see, it's very short. You just need the port, you just need the destination, source port, destination, the ASOC, then you get the checksum. On top of it, you send the data. Here, the heartbeat chunk. This is the data. So this is
right.
shorter version of TCP, the SCTP. We don't need all other. We just need the association index.
Yeah, I was altering my. Yeah, I updated my previous comments. Yeah, so directly, as you can see, after the layer 3, it's the SCTP. So there is no UDP. So it's directly SCTP. So it's not using UDP. It's not using TCP. So it's a new protocol called SCTP.
Yeah. On top of the SCTP, then we can put the M3UA.
Yeah.
This is the sample of M3UA. You can see after the IP, you can have SCTP. This is the source port, destination port. Then on top of it, you can see the M3UA. This is the sample of M3UA. This is I take the sample of Dava and Duna. And this is the affecting point code. So this is the sample layer of M3UA. If you take trace with Wireshark or any tool, I think Wireshark is globally known and free.
All right, okay. Well, this is another trace, for example, for
yeah, this is
for
if you have M3UA. Yes, this is the sample of data. You have data, then on top of the data is the SCCP. What is included in the SCCP is this call party, calling party. This will be the GT. This is the transaction ticket stack, and there's a GSM map. This is the application. And here is the sample of map. We can see here what inside this. This is SRI for SM. There is many traffic coming in the telco, and this is one of it. Is SRI for SM. Then you can see all this MSISDN. I think MSISDN already discussed with Achmad about ISDN in the earlier stage of the digital telecommunication. Now we put MSISDN. And I think MSISDN, you know it as your phone number here. Actually, I think that's it. But unless you want to show the audience about the sample tracing that I prepared.
Yeah. I think that was really good presentation. Really fabulous. Thank you very much, Jemmy. Yeah. Any question from the audience? Yeah, I just want to share about a long time ago when I was in telecommunication, I created a stack for a protocol to understand more about how the protocol works. So perhaps I can show them here. So just in case, I will start the screen. Yeah. So if everyone can see, yeah, I will decrease the zoom. Okay, so as you can see, this is a picture of how the encapsulation works. If you are using TCP/IP stack, this is the header, and then here's the layer 2, layer 3. It depends. Okay, if you are using layer version 4, this is how it looks like. If you are using version 6, IPv6, this is how it looks like, and then this is the layer 4. Either you have option for TCP or UDP. And for ss7 stack, this is how it looks like. Okay, you have MTP level 1, MTP level 2, level 3. And if you are using sigtran, so from layer 1 to layer 3, everything is similar to the TCP/IP, except on layer 4, you have SCTP here, and then you have a chunk, and then you have, And then you have layer 4 and 3-way as explained by you, Jemmy, right? Yeah, so this is how it looks like, how the protocol is added one after another. Okay, I think that's all, guys. Any questions so far? Yeah, I know this one because I was previously working in telecommunications. Yes, we do like creating sigtran and Sctp and then do ping here and there. Yeah, just to make sure that everyone or the customer can make a call. Any questions? Hello? No questions so far? Wow, looks very quiet. Oh, okay, I
think
can
someone
see
asked.
one. I can see somebody here. Let's see then. I think it's been explained before. When we use SCTP and TCP, well, I've explained TCP is a connection oriented, yes, but big problem with the TCP is TCP requires acknowledgement. Okay, so and then that acknowledgement create unnecessary delay, as Jemmy explained. So that's why we created the SCTP. So it's not UDP, it's not TCP, it's a new protocol. And then the protocol stack already explained to you a few seconds ago in my own Excel sheet that explain how the SCTP works. Okay, so it's another layer on top of layer 3 where we set up a connection. The connection is connection oriented, but it works like a UDP. There is no acknowledgement over there. Because in IP networks, yes, UDP and TCP, yes. So for Sri Astuti, I have explained the reason why we use SCTP. We don't use UDP, we don't use TCP. So we want to combine best of the both worlds. Okay, we like TCP because it's connection oriented. We use UDP because there is no acknowledgement for UDP. So we want to combine. And then we develop SCTP. For SCTP, there is a RFC for that. Okay, you can Google it, RFC for SCTP. It's an open standard, but the implementation is very, very few. Linux kernel has support for SCTP, but not much application used for SCTP. Why do you use SCTP? If you access a web browser, HTTP is based on TCP, or you don't have to use SCTP. No, so SCTP usually is created. I think this far is used for telecommunications to combine the best of both worlds from TCP or UDP. Okay, hopefully that can answer the questions, Sri Astuti. Any more questions? Oh, it's already 9 o'clock here. Wow, it's very long. It's the longest webinar ever from GSC Networks. Well, I think that's all. Thank you very much. Yeah, as the last. Okay, so we have a photo session. Please turn on your cameras. Okay, I will stop the screen share and then open the gallery.
I think someone asking Ahmad.
Oh, okay, so I have a question from Adams. It means that all telecom technologies like 2G, 3G, others use SCTP. Yes, most likely, yeah. Yeah, they are using SCTP, but in order to understand SCTP, you need to understand ss7. You need to understand how the IP works. Okay, so you need to understand how the encapsulation process. Okay, because if you only know IP, but you don't know SCTP, you don't know ss7, you don't know what the point code is, and then it's going to be useless. Right, okay. Guys, please turn on your camera. We need to have a photo session here. Okay, don't be shy. Okay, what is the command for taking a picture. I forgot. Control. No, there's no control here on Mac. What is it? Shift control. Sorry, command shift 5, right? Okay. Oh, command shift 3. Okay. Right. Okay. So I will count 1, 2, 3. 1, 2, 3. Yes. Okay. And then thumbs up. 1, 2, and 3. Yeah. Very good. Guys, thank you very much for coming. Sorry, this is very technical and then very telco. Because the things that we discuss here is not something that you see every day in your life. Yeah, you need to be part of operators so that you can witness everything that we discuss here. Yeah, yes, really sorry for that. For those who are new, and then yeah, please send your feedback, okay? And then for those who already joined, we have another webinar in this Thursday. For the details, you will see in the webinar in our website. Okay, thank you very much for coming once again, and then see you in the next webinar. Thank you very much, and then see you later, and then have a good day and a good evening, everyone.